Hey everybody, in this next video lesson, I'm going to talk about a concept known as viscosity and how it is affected by intermolecular forces. Now, what is viscosity? Well, viscosity is something that measures the flow of a liquid. Something that has high viscosity is something that has high resistance to flow, something very thick like maple syrup or even honey. These are considered viscous or high viscosity liquids, where a low viscosity liquid flows very easily, very smoothly. And an example would be like gasoline or alcohol, isopropyl alcohol, stuff like that. Even water would be considered low viscosity. So the question is, how does intermolecular forces affect viscosity? Well, as you probably would expect, high intermolecular forces hold molecules close to each other and restrict their ability to flow. So the higher the intermolecular forces, the slower it's going to flow. In other words, the more polarity or higher the intermolecular forces, the slower the molecule will flow. Let's take a look at some data down here of 4 different substances, all with different viscosities. Now, once again, viscosity is measuring in a numerical value. You don't really need to know what it's measured in. That's millipascals times seconds, but it doesn't really matter. But this number tells you how much viscosity or resistance to flow something has. A low number is very smooth, very easy to flow, and something that's got a high number is very thick and very hard to flow. But how do the intermolecular forces play a role? We'll take a look at dimethyl ether. Now, this is a polar molecule because it's got an oxygen here in the middle. The oxygen's buried in the middle of this molecule, so it's got some polarity, but not a ton of polarity, and its viscosity is relatively low. Now, acetone also has one oxygen, but do you see how the oxygen is actually sticking out off of the molecule? It's kind of out in space. Where diethyl ether, the oxygen was part of the chain, where this oxygen in acetone is kind of stuck out off of the chain. And because of that, it's slightly more polar, still polar, has dipole-dipole intermolecular forces, but not too much more polar, which is why it's similar to diethyl ether, but not exactly. It's a little bit more polar, and as a result has a little bit more resistance to flow, a little thicker. Now, ethanol has an oxygen here. Once again, it's off the carbon chain. And it's also got hydrogen bonding. So we've increased the amount of intermolecular forces by introducing hydrogen bonding here. And because it's got hydrogen bonding and higher intermolecular forces, its viscosity increases as well. Finally, ethylene glycol is a molecule that's polar, and it's got 2 spots for hydrogen bonding. It's got hydrogen and oxygen on each side of the 2-carbon chain. So it's got double hydrogen bonding, which causes the viscosity to jump considerably. So in summary, the higher the intermolecular forces, the higher viscosity. In other words, the thicker and harder it is to flow. I'd like you to take a look at this graph at this time, which shows 3 different liquids of different viscosities, and we're taking a look at how they flow or their viscosity as temperature increases. Now, this blue line represents 10-weight oil, and this pink line represents 30-weight oil. So blue is less thick and it's thinner, has lower viscosity than the pink line. And then yellow is kind of a mixture of the 10 weight and the 30 weight. It's called 10W30. Now, if you have any experience working with cars or auto mechanics or some sort of internal combustion engines, you know what the different types of oil mean. But if you don't, that's okay. The point is that the viscosity is high at low temperatures, and as the temperature increases, the viscosity decreases. And why do you think the viscosity changes with temperature? Well, increasing temperature increases the amount of motion in the particles, and those particles can then break their intermolecular forces more freely. And since intermolecular forces are broken as it gets warmer, then the resistance to flow decreases. And so they flow more smoothly at hotter temperatures. So as temperature goes up, so does energy. More energy, greater ability to break intermolecular forces. And as more intermolecular forces get broken, better flow, and the viscosity decreases. Well, I hope this video lesson explains how viscosity is affected by the intermolecular forces. Thanks for watching.